Have you ever gone to your doctor for an annual physical? One of the first things that often happens is they take a reading of your blood pressure, check your weight and height, and your temperature. But imagine if that was all they did, and then they said, "Everything looks great, have a nice day." Of course, that's not how medicine works. No single measurement tells a whole story about your health, and the same is true for our planet. Every month, scientists publish a comprehensive checkup for the Earth. The newly released report for June 2026 shows the planet just experienced the second warmest June on record, alongside historic ocean surface temperatures. But a single record-breaking month is only one vital sign. Today we're going to step back and look at the global climate the way scientists do, exploring how this combination of measurements reveals how the Earth is truly changing. Welcome back to the podcast. I'm Dr. Mack, and this is the Climate Translation. Before we can understand what this latest climate report is telling us, we need to answer a simple question. What is normal? It sounds like it should be an easy question, but in climate science, defining normal takes decades. If I asked you what the average temperature is where you live, you probably couldn't answer with a single number. After all, some days are hot, some days are cold, some days are wetter than others, some are drier. The weather constantly changes. So instead of looking at one day, 1 month, or even 1 year, climate scientists calculate averages over long periods of time. Traditionally, they use 30-year periods to establish what we call a climate normal. It gives us a baseline. Think about teaching a class. If one student scores 100% on an exam, it tells you something about that student. But it doesn't tell you much about the class as a whole. To understand how the class is doing, you need everybody's scores. Then you calculate an average. Now imagine you do the same exam every year for your 30-year teaching career. Only then would you understand what normal performance actually is like. Climate scientists do something very similar. They combine measurements from thousands of weather stations on land, ships, and buoys across the oceans, weather balloons, satellites, and many other observing systems around the world. From those observations, they calculate what is typical for a particular location and a particular time of year. The last part is important. Scientists don't compare June to January. They compare this June to all the other Junes in the historic record, and that's because seasons matter. A June temperature that's completely ordinary in Georgia would be extraordinary in northern Canada or in Australia, where it's winter. So every month has its own baseline. Now, once you've established the baseline, something interesting happens. Instead of focusing on the actual temperature, scientists focus on the difference from normal. It's called an anomaly. Let's say that the average June temperature for a particular location is 80 degrees Fahrenheit, and then this year it reaches 82 degrees Fahrenheit. Now, the anomaly isn't the 82 degrees, it's plus 2 degrees. But why does that matter? Because anomalies allow scientists to compare places that have completely different climates. A 2-degree change in Honolulu, a 2-degree change in London, a 2-degree change in Sydney. They all mean different temperatures, but they all represent a departure from what is normal for those locations. It's a common language that allows researchers to combine observations from around the whole planet. Once those anomalies are brought together, month after month, year after year, they can start to tell a story. Not about yesterday's weather, but about the climate itself and how it's changing. That's exactly what June 2026's report allows us to do. It gives us another chapter in a record that now stretches back for more than a century. So now that we understand what the climate baseline is, let's look at what scientists found in June of 2026. According to the latest reports from sources like NOAA and the Copernicus Climate Change Service, June 2026 was the second warmest June ever recorded globally, continuing a remarkable streak of above average temperatures that now stretches back half a century. If you've listened to this podcast for a while, that probably doesn't surprise you. We've talked about greenhouse gases, the planet's energy balance, and why the Earth continues to accumulate heat due to human influence. Every month adds another data point in that long-term trend. But one of the headlines that caught my attention wasn't actually about the air temperature. It was about the oceans. Ocean surface temperatures reached a new record for the month of June. Now, that may not sound as dramatic as a record-breaking heat wave over land, but from a climate science perspective, it's actually the more important measurement. Here's why. Imagine putting a pot of water on your stove. If you turn the burner on, that metal pot will probably begin warming almost immediately. The water inside warms much more slowly. That's because water requires a lot more energy to raise its temperature than metal does. And our planet works the same way. The atmosphere responds fairly quickly to changes in energy. The oceans respond much more slowly. But because they contain such an enormous amount of water, they can store an incredible amount of heat. In fact, we've talked before about how more than 90% of the excess heat trapped by greenhouse gases doesn't remain in the atmosphere. It ends up in the oceans. You can think of the oceans as the Earth's savings account for heat. Every year they pocket a little bit more energy and then release it back into space. Most of the time we don't notice. The ocean just quietly stores it away. Which is why the ocean temperatures are one of the most valuable indicators that climate scientists have. Unlike the atmosphere, which can warm and cool fairly quickly as weather systems move through, the ocean changes more slowly. It doesn't respond as dramatically to a cold front or a passing storm. Instead, it truly reflects the long-term balance of energy entering and leaving the Earth's system. That's one reason scientists pay such close attention to it. When ocean temperatures break records month after month, it means the planet is steadily trapping more and more energy. The heat doesn't sit there forever. It eventually bleeds back into the atmosphere. Warmer oceans supercharges evaporation, pumping extra moisture into the air and shifting global rainfall patterns. It wrecks marine ecosystems and, as we've talked about before, acts as a high-octane fuel for tropical cyclones. In other words, the ocean isn't just keeping score, it's actively shaping the weather we experience every day. That's why climate scientists don't just stop at temperature spikes when reviewing reports like the one from this past June. Surface temperature is only one single vital sign. To really see how the planet's doing, you have to read the rest of the chart. If you've ever had a dashboard warning light come on in your car, you know the experience of having to take it to a mechanic. But that mechanic, hopefully, doesn't just glance at the dashboard and call it a day. They're going to pop the hood to check the coolant levels, to test the battery, to read the error codes, and to look for leaks. No single warning light tells you the exact root of the problem. Climate scientists treat the planet the same way. Temperature may be the headline, but it's definitely not the whole story. Take sea ice, for example. Every month, satellites measure how much of the Arctic and Antarctic oceans are covered by floating ice. At first glance, you might wonder why that matters. After all, sea ice is thousands of miles away from where we live. But remember something we've talked about before. Ice is bright. It reflects a large portion of the sun's energy back into space. Open ocean is much darker. It absorbs more energy. So when scientists track sea ice, they're not measuring just frozen water. They're monitoring one of the planet's built-in cooling systems. The June report showed global sea ice levels sitting well below the long-term average, extending a downward slide we've watched for decades. Again, a single month doesn't give you the whole story, But when you line it up against decades of data, it's becoming a glaring piece of a much larger puzzle. And scientists are paying close attention to the water in the atmosphere. Not just how much falls, but where it falls. One of the interesting things about the June report is it reminds us there's no such thing as a global average day. While some parts of the world experienced exceptional heat and drought, other regions received well above average rainfall. I've seen that firsthand here in the Atlanta, Georgia area. It's been a remarkably wet summer compared to what people might expect when they hear the headlines about global warming and drought. And it's an important reminder, climate change doesn't mean every place becomes hotter and drier all at once. The atmosphere is constantly moving heat and moisture around the planet. As the climate system gains energy, those patterns are going to shift. Some regions become wetter, others become drier. Some experience stronger storms, others spend weeks under persistent high pressure with very little rainfall. That's why scientists don't ask a simple question like, was this month wet? Instead, they ask, how did this month's rainfall compare to what's normal for that region? And finally, we monitor glaciers and snow cover. Not because snow itself tells us everything about climate, but because snow and ice are our natural reservoirs. If you remember in an earlier episode, we talk about glaciers as Earth's freshwater savings account. They're not simply frozen landscapes. They are the storage system for water during colder months that's gradually released during warmer seasons. Changes in snowpack and glaciers can affect water supply for millions of people downstream. And what we found in June's report? We've seen a dramatic decrease in the coverage of glaciers and snowpack. So each of these measurements, temperature, ocean heat, sea ice, rainfall, snow, and glaciers, they're all telling scientists something slightly different, but they're all contributing to an answer to a question. They begin telling the story of how the entire Earth system is changing. So after looking at all these measurements, a natural question emerges. How are scientists putting this all together? Think of it like tracking a baking recipe gone wrong. If you add a tiny bit too much salt, the cake will still taste fine. If you bake it for 2 minutes too long, it may not ruin it. If the kitchen's a couple of degrees too humid, nothing may happen. None of those variables on their own ruin the batch. But when you add too much salt, then you overbake it, and you're dealing with high humidity all at once, you get a completely different ruined result. Climate science tracks data the same way. One weird warm month or an isolated dry spell isn't a disaster. But when every single metric starts shifting in the same direction at the same time, it reveals a clear, undeniable trend. No scientist reaches a conclusion because of one hot month or a melting glacier or one hurricane or one drought. Instead, they're looking for consistency across many independent observations. So is the atmosphere warming? Yes. Are the oceans accumulating heat? Absolutely. Are glaciers losing mass in many regions around the world? Yes. Is sea ice declining over the long term? We have seen that. Are growing seasons changing? Absolutely. Are ecosystems responding? Yes, they are. All of these observations are coming from different instruments, separate research groups, and entirely different countries, often using completely different tracking methods, yet they all point to the same conclusion. That convergence is why climate scientists are so confident in their findings. Their certainty doesn't come from a single record-breaking month. It comes from the fact that dozens of completely independent data streams are telling an identical story. Now, I'm not saying that every year is going to be warmer than the one before it. Natural variability exists. We are likely to have cooler years and cold winters. We're going to have places that experience above average rainfall while others struggle through drought. That's exactly what we expect in a complex climate system. But those year-to-year changes happen on top of a baseline that's continuing to shift. And that's really what this month's report is showing us. Not simply that June 2026 was unusually warm, but that it fits into a larger pattern that scientists have been documenting for decades. It's the reason why 98% of scientists say global warming is real and humans are the cause. As a meteorologist, one of the things that I appreciate most about these monthly reports is that they remind us of just how remarkable modern science has become. Every day, thousands of weather stations record observations. Ships and drifting buoys measure the oceans. Satellites circle the planet, monitoring everything from sea ice to vegetation. Weather balloons sample the atmosphere. Scientists from around the world are sharing those observations, comparing them, and building an increasingly complete picture of the direction our planet is changing. That's an extraordinary advancement, because the better we understand how Earth's systems work, the better prepared we'll be to respond to whatever the future brings. When we hear headlines about another warm month or another climate report, it's easy to focus solely on the records. But I hope today's episode has shown you that climate science is much more than chasing headlines. It's about patiently building a true picture of the planet, one observation at a time. The June 2026 report is just one chapter in that story. Years from now, the numbers will fluctuate, but every report helps us refine our understanding of how Earth's climate system is changing. That's what inspires me about science. It isn't built on a single headline, but on decades of careful observation by people who are working towards the same goal, understanding the planet we call home. I'm Dr. Matt, and this has been the Climate Translation. If you have a question about the climate you've been too afraid to ask, or if you have a differing opinion, I want to hear from you. I can use your viewpoints in future episodes. You can reach me at theclimatetranslation@gmail.com. I'll see you next time.